So today we're going to cover solving absolute value equations and inequalities. So first of all, absolute value. You guys remember what absolute value means? Who can tell me what absolute value means? Surely somebody else doesn't know. When I take the absolute value of a number, what does that mean? Okay, so it's always positive. Anybody else remember anything about it? Right, it's the distance from zero. So that's the actual definition, is that it's the distance from zero. Because do we measure distance in negative numbers? No, we probably got that drilled into you in geometry. We don't drive a negative 5 miles to the store. Okay, so that's what absolute value is. So that means that what is inside of the absolute value bars could be positive or it could be negative. So there needs to be two equations, yeah. So what you're going to do is you're going to write, first thing you do is you write two equations for the positive and negative case. So, and then you just solve it. So I'm going to write that x minus 5 is equal to positive 7, and I'm going to write x minus 5 is equal to negative 7, because either one of those is a possibility. And so if I add 5 to both sides in both equations, I get that x is equal to 12, or x is equal to negative 2. Now, generally we don't graph equations when it's just an equal sign. We're going to do that more in inequalities. But just for this one, just to kind of show you where everything shows up on the graph. I have 2. Okay, so negative 2 or 12. So what number is exactly in the middle between those two? How could I find the middle? Where's the big thing? 5. Who's that? Okay, how did you figure out it was 5? You just counted and then split it in half? Okay, that works, yeah. So they're 14 units apart, and half of that's 7, and negative 2 and 7 is 5. What else could I do? Remember midpoint? I don't know if you remember too. Okay. So anyway, so I just am showing you the graph to show you how the equation actually is in the graph. So they're both a distance of 7 from 5. So you guys see how the equation is in the graph there. Alright, let's do another one for you guys here. Okay, so we're going to solve another absolute value equation. So again, the first thing I need to do is what? Make two equations. So I've got 5x minus 10 equals 45, or 5x minus 10 equals negative 45. I'm going to add 10 to both sides. 5x would equal 55, and then 5x equals 35. So that means x equals 11, or any questions there? Not too complicated, right? You guys remember this from algebra 1? Okay, so here's what for you guys to do on your whiteboard. Look around, there should be one under your desk or somewhere nearby. Alright, so it looks like everybody's getting the same thing. We've got either a positive 5 or a negative 9. And that's another way you can write the answer is with the brackets. That's the solution set. That's another way of writing the answer. It means the same thing as up above where we wrote it with x equals 11 or negative 7. Alrighty, how about that one? Let's go ahead and do that one too. Alright, so it looked like everybody was getting the right answer. A couple of little mistakes, but most of you figured it out. Any questions? Alright, moving on then. Okay, so sometimes we may end up with extraneous solutions. So we have to check our answers. And that's generally going to happen because I've got an x that's outside as well as inside the absolute value. So if one's inside and one's outside, there's a good chance you're going to have an extraneous solution. So how do I find out if I have extraneous solutions? What do I do with the answer? Plug it back in. That's right. So plug the answer. Okay. So again, I'm going to write my positive and negative case. So 2x plus 12 equals a positive 4x, and 2x plus 12 equals a negative 4x. So here I'm going to subtract the 2x. Second one. And then I get that 12 is equal to 2x. And here I get 12 is equal to negative 6x. So when I divide, I get that x equals 6 or negative 2. So when I go back and I plug them back in to the original equation, I need to make sure I do it with the absolute value. So I've got 2 times 6 plus 12. The absolute value of that equals 4 times 6. So I get the absolute value of 12 plus 12 equals 24. The absolute value of 4 equals 24. That's true, so I know that that one works. But if I plug in the negative 2, I get 2 times negative 2 plus 12 equals 4 times negative 2. I end up with negative 4 plus 12 in my absolute values, and a negative 8. Is it possible for a absolute value ever to be positive? I mean negative like that? No. So that's not correct. That's an extraneous solution. So this one we don't use. It's extraneous. It doesn't work when we plug it back into the original equation. Okay? Make sense? Okay. Any questions? Good. Alrighty, so on your whiteboard, I can get this to work. There we go. Go ahead and do this one on your whiteboard. So I see something happening. When you guys find your answer, make sure you're plugging it back in to the actual original absolute value equation. Some people were plugging it into this equation instead, and then it was working, and so they thought it wasn't extraneous. But you have to go back and use the absolute value one. And if you do that, you find that the 5 works, but the negative 1 doesn't. And so you should have just gotten 5 for your answer. Okay? Do you guys need to do another one of those? Let's do one more. Okay, so just to draw your attention to a couple of things. So when you wrote the negative case, we needed to make everything negative on that side. And then this was one where we plugged it back in, and they both worked. So neither one was extraneous. So the answer is 5 or negative 4/3. All right, so then we'll talk about inequalities. So inequalities are very similar to the equations. We still have to write two inequalities. We have to write a positive and a negative k. But what's different with inequalities, because if you think about it, when I'm counting up with positive numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? If I'm counting up with negative numbers, it would be like negative 10, negative 9, negative 8, negative 7. So it goes the opposite way, right? So what you have to remember to do with your inequalities is flip the sign for the negative k's, because negative numbers go in the opposite direction, essentially, than positive numbers. So my two inequalities are going to be 4x plus 5 is greater than 13, and 4x plus 5 is less than negative 13. Okay? So you see that I flipped the sign for the negative case. And then you solve it just like you would in equation. So, subtract 5 from both sides on both of them. And I get 4x is greater than 8. Here I get 4x is less than negative 18. Divide everything by 4. And so I get x is greater than 2. And I get x is less than negative 4 and a half. It reduces to 9 halves, which is 4 and a half. Now, I don't know if it's an and or an or, and so I'm going to graph it to find out what happens with my graph. So that'll be my negative 4 and a half. Okay. All right, so if I'm graphing 0, or x is greater than 2, is the 2 part of the solution? Is it included in the solution? Can it equal 2 and be greater than 2? No. So I've used an open circle. And which numbers are getting greater? The ones to the left or to the right? To the right. So that would be going this way. Again, I have an open circle on the negative 4 and a half. Now it's less than, so which way do I go for less than? To the left. So when they're going opposite ways, are they ever both true at the same time? No. So it's got to be one or the other, right? So this one is an or. Okay? So you can also think of like the oars on the boat, if that helps you remember it. Okay? Any questions? Alrighty then. This one's for you guys today. Alright, so it looks like everybody's pretty much agreeing that x is less than 3 or x was greater than 4. And when you graphed it, you had open circles and it was going the opposite way. Any questions? Alright, let's do one more. Now I've got the absolute value of 2x plus 1 is less than or equal to 9. So again, I'm going to write my two cases. So 2x plus 1 is less than or equal to 9. 2x plus 1 is greater than or equal to negative 9. So if I subtract the 1, 2x is less than or equal to 8. 2x is greater than or equal to negative 10. And then divided by 2. X is less than or equal to 4. X is greater than or equal to negative 5. So now if I look at my graph for that one, okay, so if I graph just x is less than or equal to 4. Okay, so this time, can it equal exactly 4? Yes, it can. So I'm going to have a closed circle on the 4. And if it's less than, it's going to be going to the left. If I look at the other one, it's greater than or equal to negative 5. Again, I've got a solid point on the negative 5. It's greater than, so it's going this way. So the graph of this one is where they overlap. It's going from negative 5 all the way to 4. So is this one where they're both true or neither true at the same time? We're looking at where it overlaps, right? So it's an and. Do you guys remember how you can rearrange those? There was another way they used to write those. Right, and so you show it where, right, it's still opening up towards the x, yeah, and then less than or equal. Okay, so that means the same thing, that x is, well, negative 5 is less than or equal to x, which is less than or equal to 4. In other words, x is between negative 5 and 4 equals 0. Okay? Alrighty. For you guys. Okay, I think we're about out of time. Looks like most of you are getting it. I excuse you, not the bell. So you got negative 8 was less than x is less than 4. Alright, you guys are excused.